A circuit has a length of 1.8 meters and a cross-sectional area of 1.5 times 10 to the power of minus 6 meters, square meters. The total number of free electrons, which are also called charge carriers, in the wire is 2.3 times 10 to the power of 23. There is a current in the wire so that a charge of 172 coulombs moves past a fixed point in the wire in a time of 2.5 minutes. Show that the number density of free electrons in the wire is 8.5 times 10 to the power of 28 per cubic meter. Now, to answer this question, you must know the definition of number density. Number density can be defined as the number of free electrons per unit volume. Number of free electrons per unit volume. So, for number density, we use small letter n. Small letter n represents number density. But if we say that capital letter N is the number of free electrons per unit volume, number of free electrons, then if we divide by V being the volume, then this can be the definition of number density. So number density is total number of electrons divided by volume, so that we can find the number of free electrons per unit volume. So that's how we find the number density. So the question is, what do we have here? We are told that the total number of free electrons in the wire is this one. That's the total number of free electrons. We are also told that the metal wire has a length of 1.8 and a cross-sectional area of 1.5 times 10 to the power of minus 6. So understanding this, then this gives us the ability to work out this question by saying, okay, the number of electrons that are in this particular piece of wire has been said is 2.3 times 10 to the power of 23 over, now volume obviously is a cylindrical wire. We are given a cross-sectional area, even if it was not a cylindrical in cross-section, but we have the cross-sectional area and have the length of the wire. Cross-sectional area is 1.5 times 10 to the power of minus 6 multiplied by 1.8. This alone will give us the volume at the denominator there. So when you work out this question, you get that 8.5 times 10 to the power of 28 per cubic meter. That is our number density. We have answered this question based on the definition of number density. Different materials have different number densities. The one with the one of the highest number density is copper. That's why copper is such a good conductor, because it has so many free electrons per unit volume, which allows it to be a very good conductor of electricity, even a very good conductor of heat, because it is these free electrons that move to carry heat, or these free electrons that move as an electric current. The next part of the question says calculate the average drift speed of free electrons. Now to do this, we must know the general equation which has the drift speed. That equation says I equals to NA V Q. That's the equation that has got the drift speed. Okay, so in this case, our N again is number density, A, cross-section area of the wire. Then this V is the drift speed. This is the elementary charge, or the charge of the charge carrier, but in this case is the charge of the electron, which is the elementary charge, which is then 1.6 times 10 to the power of minus 19 coulombs. So knowing this and appreciating this, we then want to find the drift speed, remember. So what must we do? We must make V subject of the formula. So making V subject of the formula, we'll say I over, over N A Q. But we must remember that we are not ever told about the current. We were told about the charge. I think you can look at it here. and we are told about the time that this charge flowed. So knowing about how to look for current again, we know that current I is equals to Q over T. Current I is equals to Q over T. So if current I is equals to Q over T, then what does it mean for us? If current I is equal to Q over T, it means that we can actually find the current I using what we are given here. We are given the charge, which is 172, and we are also given the time, which is 2.5 minutes, but it must be converted to seconds, so we multiply by 60 here. Then the next thing after this is now we have the current. Now we can substitute everything. We don't have to really work out for the current. We can just substitute and then work out for everything all at once. So I can say the current here, as we have seen there, it's 172 divided by 2.5 times 60. Then a close bracket over the number density, which we, even if you had failed it to find it, but you now know that the number density is 8.5 times 10 to the power of 28. Then there is also cross-sectional area A, which is 1.5 times 10 to the power of minus 6. Then there is also the charge of a single electron, which is the charge carrier, 1.6 times 10 to the power of minus 19. Doesn't look too neat on this page, but when you calculate this, you find that V by calculation is 5.6 times 10 to the power of minus 5 meters per second. So we then write it in the space provided is our average drift speed, 5.6 times 10 to the power of minus 5. Okay.